First of all, thank you very much, everyone, for being here. And we're really looking forward to this meetup. But first, before we get started, I really want to thank Metoda for organizing this together with us and welcoming us in their beautiful office and doing this together with them. So thank you very much, first of all, for everyone involved. Thanks. And yeah, we got a evening full of talks. I would just share real quick what it would look like. So first about myself, I'm part of the ClickHouse team, really focused on the users itself. I'm speaking to a lot of users. When we started as a company almost a year ago, really focusing on finding out what our users are doing with ClickHouse, making sure that they're getting the most out of it, and helping them in general with everything involved with ClickHouse. And one of the reasons why we're here is because our users are very important, first of all. That's why we're here in Munich again. And together with Metoda, someone who pops up who wants to talk for a lightning talk, thank you very much, first of all. We got this kind of program. So we start off with Metoda's journey into ClickHouse. Why they chose it, the reason for the architecture that we chose, right, Milovan? Then we move ahead to a lightning talk from Tsvetan from Akamai as a ClickHouse beginner. Moving ahead from one of our engineers is Maksim Kita, who's willing to talk about the ClickHouse Performance Optimizations, and later on Alexey will talk about, well, ClickHouse, of course, and what he likes. One of the things I'm curious about is just to find out if there are new users, experienced users, just in general, see what people brought here. So the first question, who is new to ClickHouse? Okay, cool. Awesome. In the back as well. Who played around with ClickHouse already? So feel like, okay. And who would say that they are experienced in ClickHouse? Okay, cool. So I think we really have a good combination of talks really for the ClickHouse beginners, but also the advanced users, and really deep dive into that. The program would look like, I think we roughly stop with the presentations around 8 o'clock. We order pizzas, so pizza will be here just to eat after the meetup. And let's get going, I would say. So by further ado, I will give the word to Milovan, and we'll get started.
Great.
Yeah.
Great side.
Oh, there we go. Hey. Don't touch it anymore.
Don't touch it anymore, okay. No, break it.
Awesome. Let's go.
That's. So hi everyone, my name is Milovan. I'm here from Metoda, hosting this event together with the ClickHouse here, and I welcome you all and thanks for joining here. So a little bit about me. So I'm a head of engineering here at Metoda. I have some 20 years of experience in IT. I'm a Ruby developer by passion. So last 15 years I was Ruby building a lot of applications, and in the recent years, most focus on building applications which are handling data at scale. So my today's talk is going to be about why our company Metoda decided to go for ClickHouse, and it will be more about journey on how all the way from the problem on what we wanted to solve to some evaluations and research, benchmarking, and then again in the end the decision. So our journey is not complete. We are still not using ClickHouse in production, but we are on the way. Yeah. So a bit about our company first. So Metoda was founded in Munich in 2012. So what we offer high quality data for e-commerce. So we have some products that are collecting this data and offering this data to our customers. And we also have some applications which are specifically for processing and automating advertising in Amazon. We are Amazon certified advanced partner, and the company is around 50 plus, this is a bit outdated, a bit more people, around 20 of which is in the IT sector. Some technical facts you might be interested in. So we process around 10 terabytes of data per day. That is throughout all of our applications. We have a lot of applications running. Some of applications are SaaS applications that we offer to our customers. Some are consulting projects that we are working on. And so it's really a big mixture of things that we have. We have around 50 production stacks running in our Kubernetes cluster. And what's also maybe interesting for you is that we also have some kind of in-house data management solutions built by ourselves, things like ETL or file system or some things for cataloging the data in the data. So again, why ClickHouse? So why we decided to go with the ClickHouse? So I'll start with first, what was the thing we wanted to achieve? So in our cloud, we have a typical app would look something like this. So what we want to offer is some insights from the data on to the customers, and we also want to make this also actionable. So we're not building read-only dashboards of things. We want to have interactive applications, and this would involve something like this. So we want to allow users to be able to filter by data, to filter data by date ranges. We want to have some kind of customizable chart or multiple charts or dashboards. Users should be able to filter by any column or anything in here, and even some of these columns could be aggregated facts, something like I want to filter by the total number of this fact in this specific date range. Of course, users would like to also sort by things, and on top of this, of course, we want to add unlimited history. That's something that VMs would like, not us, but yeah, that's one of the requirements. Also, that this data can be changed at any time by users. So we want to have a solution where user can change something and that change can immediately be applied, and users can, for example, filter by this some kind of value that they inserted. So solutions like typical BIs where you just load the data and then you have some kind of dashboard of it, does not work for us. So we needed something more interactive. And of course, this needs to load fast. So that was one of the big requirements. So we don't really want to have dashboard like this where user clicks on something and waits 10 seconds for the page to refresh. So what would be a typical implementation? So this would be most pragmatic thing. If you're starting a new app, you would probably most likely choose the things that you have at your disposal. So you will probably go with your own OLT database. If you have it in your application, you say, okay, let's just load the data in there and see how it goes. And for the start, it's quite easy. You just join facts, join dimensions, everything works. You build a dashboard, it's fast, it's working, and it's simple, it works, and it can be shipped to the users. But the problem is, after a while, things are getting to become slower and slower and very hard to optimize. And once things become slower, then the typical next step would be to understand why the things are so slow. So that would involve a lot of work in profiling and fine-tuning the database queries and trying to understand really where the problems are, trying to solve them. And one can get quite far with this. So typically first implementation is not that good, you can optimize it. Now it's better, now it's faster, but the time is catching up, especially if you are offering things like unlimited data history. It means that not only the number of clients is affecting you, it's also the time is working against you. So every day you have more data and it's getting harder and harder. So what you can do is you can also scale up the database both vertically or horizontally by adding read replicas or something like this, which can get quite expensive, quite fast, and quite complicated also to manage. You can do data partitioning or trying to optimize the very ingestion of the data to make sure that the things are getting into the database in a proper way and that you're not working against the database. And this can get you to some point. But the problem is that over time, the developers who are developing the app are starting to feel more like database administrators. It's not that it's a bad thing, but if they are doing the database administration job, who's going to do the application development? So the new features, the development of new features is slowing down because we are having to fight the database problems. And at some point, people ask, are we still using the right technology? So more experience would tell from the very beginning that the Postgres is not the right tool for the job, but it's also a pragmatic decision to use it because it's quite easy to just develop with it and to some number of years or months, it will work. But at some point, it is getting more and more painful, and then you can ask yourself, is this really the right tool for the job? So what we did, we tried out some alternatives. So we already had experience with most of these in the past, but we also wanted to try them out once again with these specific use cases that we have in Metoda. So what we tried is we use a couple of AWS services because our applications are developed in AWS cloud. So that was the logical point. Let's try using some of their technologies to try to solve the problem. So what we used, so what we tried out here was Amazon Athena. It was very scalable, very easy to use and quite easy to integrate because our data was already in AWS. But the problem was that it was way too slow. We did try it out maybe 5 years ago. Athena is now much faster than it was before, but it still has, it's just the architecture of it that it has a cold start and you cannot really use it for things like this. So it's just not something that we could use. So the response time that we could get from Athena were ranging between 2 and 5 seconds for some of the more complicated query that we had, and that was not good enough. The next thing that we tried was the Redshift. It was a faster solution than Athena, but Redshift is a different concept. Redshift is not a serverless, so you provision a server and then you can load the data inside. It can process the data. It was fast. We were able to use it to get to a response time that were good enough. But the problem was that the Redshift was not really scaling well in terms of concurrent users. So you can throw in, as soon as you add more concurrent queries to it, it's starting to get slower because it's just how it works. It's very good at processing the data very fast, but it also has the queues on your queries. So unless you have a very large cluster with a lot of nodes in it, you cannot process enough queries in parallel. And so it can work, but it can be very expensive to scale. The next thing we tried was Elasticsearch. It was quite fast, so from that perspective, it was really good. But the deal breaker for us that in Elasticsearch, there was no option that you can join two indexes and then run a query against two indexes at the same time. And that was a big problem because our data, we wanted to offer users to be able to update the data, and as soon as they update it, to be able to query it. And if we denormalize the data, then it would be a problem because on each update, we'll need to reindex millions of documents in Elasticsearch, and that was not really optimal. And so the last thing that we tried was the ClickHouse. I had experience with ClickHouse in my past company, so I knew that it could fit this into this. But in my past company, that it could fulfill the requirements. The problem in my last company was that we didn't have enough DevOps power to actually put this into production, which was a deal breaker. So at that time, there was no cloud solution for it, so it was not for us. Simply not possible to run something like this. So we did some very quick evaluation of ClickHouse, and it was kind of promising. So we managed to load the data in, ran some random queries. It was running fast. So we decided to run some proper benchmark on it. So what we did is we took one of the applications from our suite, which was kind of not the smallest one, but not by far the biggest one. And it was kind of like one of the applications in the middle. And we wanted to try out with the data that we have in there. So it was the data set was consisting around 150 million rows of facts and around 1 million rows of dimensions. And we wanted to run some queries that are going to go through the data. So the queries were picking between top accounts and then doing this random 30-day interval period. So we were trying to hit really whole data set, randomly hitting the whole data set, which is basically how things are working in the current production app. So we have a lot of users just hitting random dates, random accounts, random everything. So which gives you not much option to use some kind of caches. And the benchmark was done for 10 concurrent users and running requests every 2 to 3 seconds, which was something that we wanted to see whether if a single node, which was a really modest amount of RAM, can do something like this, then it could be something that could actually work for us in the production. So we did these benchmarks. We used the K6 tool for running this. It was quite easy to set up given that ClickHouse has the HTTP API, then it was just very easy to run these kind of tests. So what it showed is that for these kind of queries, we can get around 200 milliseconds response times, and this is the average. And it was really ranging from around 30 milliseconds if you just run some isolated single query, but it was going, if you hit it with a lot of concurrent users, these were some kind of stats that we got. And we compared this with the same benchmark that we did on the Postgres instance, but it was, again, not easy to compare these two things. Postgres had 64 gigabytes of RAM, very large instance, running on the same data. And with the same kind of benchmark, the Postgres was performing 10 times slower. So it was, for us, clear that at this point, this could be a technology that we could use and that it can actually scale and meet our requirements. Yeah, so this is just the gist of the benchmark results. Some considerations here is that the benchmarks that we ran was against really fully sorted and immutable data, which is never the case in production. So data will be appended. It needs to be in the background. The merges need to happen. Also, the data will become not sorted over time. So on the production, we know that things will not be like this. But on the other hand, this was run on a very limited machine. And in production, we will have something much bigger. So talking about the next steps for us that we took, so we evaluated how we would get the data in our systems. So that was the easier part of the story. So given that we work on AWS and that we have all of our data in the cloud on AWS, so it's already can be easily exported to S3. The functionality of ClickHouse to actually load the data directly from S3 really helped us. So that part was just working really fast and really smooth. The other thing that we had to consider is what's about the updates. So how do we deal with all the updates of the dimensions that are happening all the time? And that was also handled quite easily in ClickHouse with the replacing merge tree. So we would just, from the application, stream the new records with the updated version flag, and then in the background, this would be merged. On top of this, we will put some kind of a view to hide all of this away from the application itself who will be using this. So this kind of thing was quite straightforward. But there were a lot of other considerations here. So getting the data into the ClickHouse, technically, it's quite easy. Setting up the schemas or everything in there requires expertise, but again, it's not a problem. The bigger part of the picture here and the bigger problems were more related to the other concepts, which are related more to the data management aspects of this. So if you have a lot of products in your organization, and these products are all data products. Chances are that there will be some dependencies between these things. So as soon as your data leaves your application, so it was in your application, in your Postgres database, and now you want to move it away somewhere, so you want to put it in a ClickHouse, chances are that the others would like to also use this data. And then it is really important to understand what kind of data each of your application is publishing, how it's produced, when it's produced, how you can access the data. And even more importantly is who uses this data. So who of your, inside of your organization, of the application that you're using, processes or whatever, is accessing what part of data, and maybe also to understand for what purposes. If this is done wrong, then over time, over years, and we learned it in some other project that we did, it can result in a really complicated dependency mesh that nobody understands, which will lock you for years. So if you want to change something, I want to change this column, add this, or do any kind of reorganization of data, things will start break in a lot of places. So unless you understand really dependencies well, you should really be careful about doing this. Another consideration here was also that if you're going to make the data available outside of your app, you can also try to make this data reusable by other products. So, for example, if the easiest thing is just you have an application, you push it to a ClickHouse, but it would be much more flexible if you actually store this data somewhere where it can be reused. And if that data is there properly cataloged, then you can reuse it in other ETL processes, or you can reuse it in any kind of AWS tools that they are. So if it's structured in a good way, then this same data can be used by ClickHouse, but it can also be used by Amazon Athena. You can load it into Power BI if you need to. You can do whatever you want really with it. And the last consideration as well that I also faced my previous company was about managing the production environment. And this is really a deal breaker for a lot of smaller companies because this thing is quite complicated. If you want to run really a production cluster and you want to ensure all the things that should be in place, if you want to run something really reliable, then it takes a lot of power from the company to do something like that. And for us, it was really good that there is a cloud solution that can be used and that we can really leave this whole big amount of work to them. That's why we joined also the private preview program in the ClickHouse, and it was really a great experience with them and the thing that they are building over there. This is where our journey is at the moment. It's not where it ends. So what we are going to do in the future is we're going to proceed with this idea. At the moment, we did loaded our data to the ClickHouse cluster in the cloud. And what we want to do next is to work really on this concept of data cataloging, dependency, and everything else, because we want to be really careful before actually publishing the data so that we understand where this data lands, who is using it. Yeah, that would be it from my side. Thanks for your attention. Any question? Yeah.
I'll grab it. Is there a question?
So I guess that the migration is still ongoing process. And do you plan to kind of run it side by side with the current database that you use? So what's your plan? Do you plan, for example, to enable ClickHouse queries to go? I mean, a set of customers to use ClickHouse just for like private customers or beta customers. So what's your strategy?
Okay, thanks. It's a really great question. What we plan to do is to run this thing in parallel. So all the data that we actually load in Postgres, we are going to load it in parallel to the ClickHouse, and then it will give us the option to actually benchmark the performance of both systems, which are on the data, which is changing like live data. And after that, we can release this either to, we have the separate beta production environment where we do these kind of testings, but we can also roll out canary releases to specific customers or something like this. So that's a good question.
Hi. First of all, thank you. That was really interesting. Now that you run ClickHouse on your production stacks, I wonder if you still need to tune the systems, for instance, create indices, partition data in a certain way, or even tune some of the more specific knobs like the data compression. Is that the case, or is this like ClickHouse just fast enough out of the box?
So we still don't use it in the production, so we will get to that point of using it. Our plan is to really for the data to split it. So in the end, the fact table, the big tables will not get into the Postgres at all. Dimension tables will still stay in the Postgres. So in a sense, we will need to do a lot of tuning, but given that the amount of data will be drastically cut down, it will be much, much easier to do these things. So it won't need to be really perfect tuning, so we can relax a little bit there because the volume of data will just be smaller, but it doesn't eliminate the database tuning. Yes. Thanks.
So thank you for the wonderful session. So in the initial slide, you mentioned aggregation was one of your requirements, right? And you have 10 terabytes of data. And are you planning to let the users letting the end users to make the aggregations by themselves, or you are doing it via some kind of a neutralization?
Okay, thank you for the question. So it depends on the product that we have. We have some products where we actually do this aggregation up front and we prepare the reports, in which case we also going to use similar technology. So that's why this particular step that I showed in the last place, where we actually want to have the data available by other tools like ETL as well, is important for us. So that way we can have the data in ClickHouse to run queries on it, but also available by ETL or some processes to prepare this aggregation. But on the other tools that we have, like this dashboard that I show, the data behind is really the raw data on the raw data, and users are specifying basically on the fly this aggregation level. That's why it's so expensive computationally. And when they want to show the page, database really needs to go through some 100 million rows in order to be able to render this small table in the chart. That's why this is a problem. It could be thought from the other side. So if we, for example, offer users some predefined date ranges or something, we can prepare and pre-aggregate stuff. But given that we want it to be fully flexible and say, okay, give us any kind of date range, any kind of filter, any kind of anything, and we will show it, then it's getting really complicated. And then we need to do this all on the fly.
Thanks, Milovan. Cheers.
Thank you. If you have any more questions about Metoda or about this presentation, you can also reach out to me later. And if you have questions or you want to contact Metoda directly, Kat is there, or this is also there, so you can reach out to them. Thanks, everyone.
Yeah.
Yeah, thank you.
Yep.
You got it?
Hello, everyone. My name is Tsvetan Stoychev, and today I'm going to be talking about my journey as a ClickHouse beginner. And first, I'll just say a couple of words about me. I come from Bulgaria. Maybe you catch it by my accent, and I don't even try to hide it. I'm proud of it. Yeah. I love to like a bit more personal about me. I like to walk with this white Labrador around Lincoln. It really helps me to recover after the long working days. Work from home is not so healthy. And yeah, when I have free time and when I shave my beard, I do some street art. This really interesting activity. And yeah, I'm the guy with the saxophone. So I guess some of you notice these people who like this live statues painted with gold, silver, or any other colors. Yeah. But yeah, now let's dive in more to the professional topic. At the moment, I work in a company called Akamai, and in my free time, I work on an open source project called Basic Run, and I use ClickHouse for it. I'm still experimenting. And so what is Basic Run? So here we have a simple, very simplified diagram of Basic Run, and it basically collects performance data from browsers. It sends it to a remote web server. We do some massaging of the data, and we persist it in ClickHouse. And to the last stage, like from the user point of view, we render the data with Grafana. And yeah, but let's first talk about my relationship with ClickHouse. I'm still a beginner. I'm a script kiddie. I guess some of you know what is it, but I will read for you the Wikipedia description. I hope that I'll get it right. A script kiddie, skiddy, or skid is a relatively unskilled individual who uses scripts or programs, such as web shell, developed by others to attack computer systems and networks and deface websites according to the programming and hacking cultures. So I'm not really trying to hack or to bring websites down, but basically I behave like a script kiddie because I'm still learning. I just copy paste a bunch of snippets that I found on Slack channels or Stack Overflow, and I play with them. Yeah, and I want to learn. And for me, like from my point of view, what I need to make learning a productive process, the first one is just to have a playground, something that makes it easy for me to experiment. And the other one is that I need a source of information. I need to find the right, the right documentation. And yeah, let's look at what I do for playing with ClickHouse. So the easiest things that enable me to play with ClickHouse, and because I'm more like a visual person, I like user interfaces. So when you run ClickHouse locally, for example, you can just on localhost on port 8123, when loaded, you'll see this user interface of ClickHouse, so this built-in user interface, and you can just run an arbitrary queries, and you get the result rendered in a nice table. By the way, this is a question for the ClickHouse team. So what is this thing here? I suspect what it is, but it looks like something base 64, but what is it inside? So let's imagine you are script kiddie, but you are becoming more and more experienced at script kiddie. So you will just copy this base 64, paste to terminal, pipe to base 64 minus D, and you will get JSON. And this JSON will contain the state, this query, and something else. So, yeah, thanks for the answer. I suspected that was my approximation, and actually, that's really cool. If I talk to somebody else, if I want to corroborate with this person, I even just can send them this deep link. I mean, I can send them this query as well, but also the deepness will work for them. Yeah. Something else that enables me, and probably you noticed that I try to use Grafana for my open source projects. But yeah, Grafana also is like my another playground. And here at point one, I'm using a data source plugin built for Grafana. I think initially it was built from somebody from Cloudflare. Now, at the moment, I think it's maintained by Altinity. But yeah, I just can use ClickHouse in Grafana. I can query it. And here in point two, there is a text area where I can just write queries. And if I choose to render the data as a table, yeah, in point three, I can view the data. And what I'm doing here, I'm just running a count query, and I want to sort the most popular pages by visit on a website. And I also can actually save this. So this is the Grafana panel. I can save it. And yeah, Grafana also has versioning. So if I want to go back to a point in time, I can go to, let's say, version 15. And what I also do very often, I clone panels. For example, sometimes I want to just add something extra in the where clause. I want to look at some other dimension of the data, and I want to have the both panels on the same page. So this again, it's a quick trick that works for me. Yeah. Something else that I do, I still try to figure out the right schema for my application, and I do something again on my local machine. It's pretty dirty, I would say, but it's just a script that from time to time recreates, just drops my test table and create the table with a new schema. And after that, I just populate. I have another script that fills the same data every time to the new schema. Yeah, and here are the steps like. So I run the script, drop the table, and it creates my table. Something else that also enables me to experiment. As I say, my schema is still not defined. I still experiment with different, say, codecs. I try different combinations of data types for columns. And so my data comes in JSON. It comes from files that they contain JSON. In each line, I have a separate JSON string. And again, I experiment a lot, and I use the input format skip unknown fields too. So, for example, here I have it's very simplified schema, but I have the column C1 and C2. But here you'll notice that in the JSON, I have C3, C999, C9998. And if I don't have this, just ClickHouse will throw an error and say that it doesn't recognize, for example, C3. And as I say, my schema is still fluid. So this just allows me to iterate faster. I don't need to think about the schema. As I say, I'm beginner. I don't know what I want at this time. Yeah, and now let's talk about studying. I need to find the right information. Yeah, one place where I find a lot of useful information when I ask a question is the ClickHouse Slack channel. Yeah, for example, here I shared my thoughts on a query, which I suspected it's not really efficient. And in a couple of minutes, I believe in just in about 1 hour, I got a suggestion how I can make it, how I can optimize the query. So I just adopted the idea that Robert Hodges from Altinity shared with me. So yeah, I have to say that the community response on Slack is really good. I try to get help in other Slack channels for one programming language and for one visualization tool. I'm not saying the names, but the channels there are overcrowded, and you just ask a question and you hope that somebody notices it. But I think here just more people also, like the ratio of people who need help and who can help is really good. Yeah. The other thing, this is the first tech channel that I'm subscribed to YouTube. And actually, that's how I found ClickHouse. One of, yeah, there was a YouTube recommendation. I clicked on it about maybe 2 years ago. And yeah, Alexey was presenting something. But anyway, so what I do, I watch, you see, I watch from time to time the release webinars, for example. And fun fact, it happened that I watched even when I was in the gym, warming up, stretching. But still, you know, I'm not obsessed, but I try to. I know that I need to. But okay, if I want to master something, I need to invest time.
Yeah.
And but during the day I work. So okay, let's just listen. And I hear some keywords, and then I remember them, and then I probably later I'm indexing. Let's say that. Yeah. I also last year took like a free workshop from Optinity data warehouse basics. I don't think that at the moment this workshop is available for free, but this also was a really interesting experience. I joined the workshop with 3 other people, so we were given small assignments, and there was a bit of competition. You know, I like this group dynamics. Yeah. And I also subscribe to the Optinity channel, where they also talk a lot about ClickHouse, and I think they do more like deep dives on different ClickHouse features. But yeah, also a good resource for people to want to learn. And yeah, I guess some of you or most of you know this phenomenon when you want to explain something to somebody or you want to teach somebody something, you understand it better. You learn it in the same way when you explain it to somebody. So yeah, I'm a part of the web performance community, and every year in December we have this event calendar. So we post articles every day, and I decided to write something about ClickHouse just to introduce it to my community, and I understood something better about ClickHouse. Yeah, and yeah, kudos, really great community. I don't know why, but probably it's effort from the community members and from the most from the ClickHouse side. Let's say it feels that when you ask a question, you get an answer. Yeah, and again, I added this slide before, like 20 minutes before I need to given the presentation to be loaded, and as you see, I'm alone on this project. I have actually a lot of technologies here. I have a Go web server. I do a lot of data manipulation. I need to learn more about Grafana. I probably will start writing plugins. Here, actually, there is like a JavaScript agent that runs on the browser. So you see that there is a variety of technologies, and my problem was in the past few years was where to focus. And one thing was, okay, I need to find the right technologies, but when asked where to focus, I cannot focus everywhere at the same time. But the statement that I try to say is having the documentation and the community and the resources really makes my life easier in terms of spending less time on researching ClickHouse. Just it's more efficient. And yeah, that's it.
Have time for 2 questions. I don't know if somebody has a question. Otherwise, after we move ahead. Thanks. Thank you very much. Cheers.
You use this one? Yes. We just started the box. It's
Hello. Uh, Hello everyone. My name is Maksim, and today I will talk about ClickHouse Performance Optimizations. So a little bit about me. In ClickHouse, I am responsible for dictionaries, for JIT compilation, for user-defined functions. I also responsible for a bunch of performance optimizations, and currently I'm working on query analysis and query planning. And today I will talk about performance of ClickHouse. So why it is important? Because performance is one of our main selling points of our product. So my talk will consist of some 6 small sub-themes. First, we will talk about high-level system architecture. Then we will talk about CI/CD pipeline. Then we will talk about some introspection, some abstractions which we use. Then we will dive a bit in libraries. And after that, I will show you some ninja tricks that you can use to improve performance of your system. So let's first start with high-level system architecture. ClickHouse, most of you know, is column-related system. We have column-related storage, and we store our data in columns. Why it's necessary, why it's important, because only necessary columns are read during query execution, and also the data is compressed much better because of data locality. But we not only store data in columns, we also process them in columns. We have vectorized query execution engine. In this engine, we process data in blocks. Blocks are just an array of columns, just multiple columns, and each column is just an array. So it's some array of some basic types. If a column is some compound type or some complex type, it's some composition of these columns, which such approach, such vectorized execution engine can help us because compiler can perform much better optimizations for caches, for CPU caches and CPU pipelines. Such architecture is very friendly. Okay, and a big dive in ClickHouse columns. So we have numeric columns. It's just an array, the same as to vector, but with a bit of additions. For example, for nullable column, we have like array of data and a bit mask if element is nullable in this array or not. If we have array columns, it's just a column with data and some column with offsets. And for const column, it's just some constant value. Okay, and let's talk about CI/CD pipeline. So I did a lot of optimizations, and from my perspective, this part is the most important one. This part is related. This part is our CI/CD pipeline. So what we have here? We have functional and integration tests. We run all our tests with all possible sanitizers, ASAN, SAN, and TB-SAN also. Yes, we have fuzzers. We pass data types. We pass compression codecs. We have special ISP fuzzers that can build your query and fuzz it. We have special stress tests when we attack ClickHouse from all our functional tests at once, and we see if it survive. And we also have performance tests. And performance tests are the most important part. We shall talk about a bit deeper. So what is performance test? It's part of CI/CD pipeline. We run it on each commit, in each pull request, and on each commit in master branch. So how it look like? How the report look like? So we have a commit. We have some commit message. We have query. We can see our performance test can detect some changes in performance. We can see like which test it is, which query it is, and the performance changes. And also during each performance test run, we collect a lot of metrics. I will talk about metrics a bit later, but we really collect a lot of things. And I want to tell also that this tool is not only about finding the regressions. It's obvious that you can find a lot of regressions with this tool. Like you add some code and performance becomes slower. But it's also a very important tool to find places to optimize. In our system now is mature. We have a lot of tests, and for example, I can
change something in compiler, try some different allocators, change, for example, instruction set. For example, I can like change inline threshold in compiler and see if we have some changes in performance. And okay, I see some functions are improved. Then what I will do? I will go and fix them using my hands. So basically, I can add specializations. I can play with some settings for specific functions and get system performance improvement, but do not, for example, apply these changes to all systems. Okay, so now let's talk about introspection. This thing is very important. So basically, what we collect everything that is possible to collect from user space. So we collect using get resource usage some things. We also use cross file system. We also support a link interface. We collect like everything that you can collect, basically. But very interesting thing that mostly no one knows about is that you have a pair start in ClickHouse for each query. And why is this important? Because you can use these things, for example, on your cluster. You know, you run a query, it's on a lot of machines, and you can grab these things from the whole cluster. And we also collect a lot of ClickHouse specific metrics, like how many files we open during the query, how many functions we compile using JIT compilation, and so on. So basically, this is an example how you can get data from our system query log. It's very easy. Okay, and last but not least thing is the traces collection. In ClickHouse, we periodically collect all the traces for all threads, and this can be very helpful for you to later debug. Currently, we use patch fork of LLVM library. And for example, you can, if you have some problem and want to know what's going on with your cluster in current thread right now, you can just use system stack trace table and see. So here we see that the server waits on condition variable probably until some data will arrive. Okay, and very interesting thing is that if you have stack traces, you can like use another tools like flame graphs. So what's flame graph? You can read more in this article, but it's built on top of stack traces, and you can see how many time you spend in each function in ClickHouse. So it's a very good thing. If you, for example, have performance problem, you can grab this thing and attach it to issue on GitHub. Okay, now let's talk about abstraction and algorithms. Alexey already did a lot of talks on this thing, so this is one of his talks. But the main points here are like this. So for high performance system, interfaces must be determined by your algorithms. So top-down approach does not work. And also high performance system, if you design high performance system, it's very good if you like do one task efficiently, at least one. And you should design your software from the capabilities. So for example, you try to test some algorithm, and you must understand like limits, hardware limits on your algorithm. And ClickHouse was designed to efficiently filter and group by data and aggregate data that fits around. And for you, some additional information. So there is no like silver bullet, like some best algorithms for any task. You should try to pass the fastest algorithm for your specific tasks, for your concrete scenario. And very important thing is that performance must be evaluated on real data. It's like must have, because all algorithms are very much affected by data distribution. And I here listed some suggestions from my side. So basically, you can view some complex task as a number of some small tasks. For each small task, you can view it like some specialized case, and this specialized case you can like tune with some concrete algorithm. And after that, after you like build your system with these interfaces, you can use different low-level optimization. So like Git compilation, you can try to play with data layout, you can like fix bits. Okay, and also I will talk about example, for example, like aggregation in ClickHouse. So initially, the main idea, the main design decision is that data is processed not only by single server, but it's processed in the whole cluster. Core component of our aggregation is the hash table framework. So our aggregation is like abstraction around this hash table framework. And we use different hash tables for different type of keys. For example, we use special string hash table for string. Then we add also a lot of different specializations for nullable, for low cardinality. We tuned a lot of low-level details, fix some allocations, fix some data layouts. After that, we added Git compilation for a lot of special cases. And after we added Git compilation, recently we added also a cache in our group by for hash table size. And also one point that optimizing performance is about trying different approaches and most of the time without any like results. Okay, now let's talk a bit about libraries. So if someone on the internet says that his algorithm, his approach, his library is the fastest one, we will try to use it in ClickHouse. Currently, we have like 95 some country models, and we have like different libraries that pass JSONs. We have like a lot of integrations, some storages, some. We also have LLVM for Git compilation, and we also have a C++ standard library. Almost in any library, our CI system finds bugs. It's okay. We report them to maintainers, and we are not afraid to add additional contrib. I know in a lot of projects, people are concerned about adding some third-party stuff. We are not concerned. Our CI system will do the job and find if code is good or not. Okay, and now about some hacks which you can use. So I'll talk about Git compilation and dynamic dispatch. So what is a Git compilation like? In very fast explanation. So Git compilation can transform some of your dynamic configuration into some static configuration. And it has some obvious costs. So basically, it's compilation on runtime. You also spend a lot of memory. It's some additional maintenance costs because you need someone in your team to understand how it works. But it can greatly improve performance in special cases. And in which cases we use it in ClickHouse. So for example, we use it for expression compilation. Here we have some query like select A plus B multiply C plus 5. And in most of the systems, this thing works like you build an expression tree, and your engine need to evaluate this using this expression tree. In ClickHouse, we have the similar architecture, but in this architecture, we have problems. We have a lot of virtual function calls. We have a lot of indirections. We need to store temporary results somewhere, and Git compilation can eliminate all of this. So basically, you compile this thing in one function. It will lie on a single page. It will be much faster, and compiler can optimize it much better. You can compile special cases. We compile special cases of group by. We compile comparator and in order by, and in all of these cases, we could convert the dynamic configuration into static. So we avoid some additional virtual function calls and other stuff. And I also have presentation from C2+ Russia about Git and ClickHouse. Okay, and now about dynamic dispatch. So currently ClickHouse is distributed with old instruction set SSE 4.2, but recently probably we will move or already moved to AWACS. It's a bit outdated. And for other instruction sets, for example, for AWACS2, for AWACS 5.1.2, you need some, runtime dispatch. So basically, you use some special processor instruction. CPU ID, you detect your hardware capabilities, your instruction set, and in runtime you can dispatch it. And it's also important to keep in mind that for example, you have some function with some loop, and compilers are smart enough right now, so you don't need to manually unroll it, manually try to apply some optimizations. you can basically tell the compiler to compile this thing with, for example, AVX2, and it will work much faster. So the main idea is just to apply some flags to some functions to compile it with different instruction sets, and in runtime check CPU ID and use specialized functions. And it's like recent, very recent improvements. So basically, we improve performance of binary functions and performance of group by functions when there is no group by expression. And for AVX2, we use such optimizations like a lot, almost everywhere. If you can, for AVX 5.2, currently we do not use such optimizations a lot because there can be potential side effect known as down clocking. But for recent processors like Rocket Lake or Ice Lake, they fix this issue, and we can detect such processor in runtime and use optimization. In conclusion, so CI/CD infrastructure lies in the core of our performance of ClickHouse. We also have a great introspection. It's very important. For high performance system, interfaces must be determined by algorithms. And after you determine your high level architecture, you can start to add specializations for some special cases. And after you do all these things, you can tune low level, use some low level optimizations, tune your data layout, use a Git compilation, use dynamic dispatch, and possibly you can write another ClickHouse. Please conclude. So that's it from my side. Do you have any questions?
For CI, then I understand correctly that you are using ClickHouse to find performance regressions in ClickHouse.
Yes, that's right.
Mhm. Okay, and did you try some time series DD that looks like this?
No, we use ClickHouse, so we use our own product.
What do you suggest?
It looks.
It will be not better than ClickHouse. I put it mildly.
Yes, you have some metrics like performance, and we need to check.
Yeah, I know. But you know that ClickHouse can be used as
Yes,
time
yes.
series data. And right?
Yes, I have an article about using databases in CI, but that's
And you know, if ClickHouse is not put in this scenario, we will suffer. And we will suffer until we will make it.
okay. So another question. So for plain graph, in Intel and Vitune, we have plain graph analysis integrated. So probably you can use into Vitune like a tool instead of manually collect events for their things.
It is very interesting. We have added per events into ClickHouse to be able to measure every single query. And even if you run multiple queries concurrently, we collect the statistics per query. This is not possible with Vitune.
It is possible because in Vitune we have ITT API, and you can enrich all query with ITT API.
Ah, yeah, it means we still have to try. Maybe Maxim will be interested.
Yes, about libraries. So we have Hyperscan, and in ClickHouse you have special build of Hyperscan. So why we not using one with big manipulation instructions in this process?
Actually, I'm not sure why. Maybe probably we have some our CMake wrapper around this. And for example, if you I'm not sure in Hyperscan these optimizations are in runtime. So basically it will
In recent versions of Hyperscan, you have big manipulation instructions that can be very good for comparison of
actually not sure. Maybe we just not use the recent version. Maybe.
No, we do, and even more recently we have replaced Hyperscan to its fork, named vector scan.
and the reason is to support not only x86 but also ARM. And about AVX 512 DMI. If it is runtime dispatch, we can use it. If it has to be selected in compile time, we don't use it and cannot, because we need one ClickHouse binary to work on different CPU architectures.
So not fat binary.
Yeah, not fat binary. We can compile multiple versions of Hyperscan and detect in a runtime. By the way, Hyperscan is quite fat, about 400 megabytes with debug info. Thank you.
So one more question, and then move to the next one. Oh yeah. Robert already was question, then we go to.
So for dynamic dispatch, you mentioned that this is something that ClickHouse is doing automatically when we are running it. It can detect even on runtime and which optimizations to use. So I wonder if this is something that we as users of ClickHouse, is this something that we should be aware of to make our ClickHouse more efficient, or use what it has available, or can we trust that ClickHouse will take care of things and we don't have to worry about it?
Related dynamic dispatch, you can trust ClickHouse. So we will use the best possible options here, but related to some options that you can specify to improve performance, there are like a bunch of such options. We have a lot of experimental things that you can use and other stuff. So basically, if you like need to tune maybe one or two queries, like you can tune it very much.
All right, thanks. Thanks, Maksim. Cheers.
So I'm Alexey, and I'm supposed to give you ClickHouse engineering update to tell you about new features. But the problem is we have too many new features, hundreds maybe. And if I will go and just list every new feature, it is going to be boring. Instead, I will tell you just about some subset of my favorite features. And also, I will ask Anne and Nick to prepare the gifts. Do we have?
Yes, we do. Of
Perfect.
course we do.
To make my presentation less boring, I will also ask you to try to guess what are my favorite new features. Not yours, but mine. And if you will guess correctly, I will give you a t-shirt. This t-shirt. So let's start. Yes, you can tell me about your favorite features, but I will be very happy if your favorite features will be the same as mine. So let's try to guess something from the last half of year. So what do you think? What is my favorite feature from the last half of year? ClickHouse benchmark. You are almost right. You are almost right. This is one of my favorite features, but not the first. And I'm asking what is like the most favorite feature. Almost ClickHouse. Almost. You are almost right, and you are almost getting our t-shirt. Please keep it for 1 or 2 minutes. Schemaless definition. Maybe, but don't you cheat? No, you don't. Why do you already have our t-shirt? Just a coincidence. Okay. Okay, let's look what is my favorite feature. Schema inference. and you will get a second feature. So what it is? It is difficult to notice that this feature even exists. But if you compare how it was before, how it was 1 year ago, you will notice a huge difference. So how it works now? You can easily select from whatever file, and you don't have to specify the schema. It will be detected automatically. Compression will be detected automatically. Data format will be detected automatically. And column names and data types will be also infinite. And you can read the schema with describe query. Describe any table function and it will work. How it was 1 year ago? It looked like this. Just compare the same query. Select from URL. Now it is pretty easy. 1 year ago, you just had to specify schema manually. So what else? Table structure is detected automatically from files, from structured files. If you have these files in native, protobuf, Avro, Target, or Arrow, don't be confused between Avro and Arrow. I'm not sure if I pronounced correctly, but we have support for both. And even if you read from unstructured formats like CSV or CSV with names, CSV with names, these names will be automatically used, and data types will be also infinite. Let's look how it works. So imagine you have some file with JSON, and the names will be from JSON, and data types will be inferred by nullable string or nullable float 64. Arrays will be also inferred, and even multi-dimensional arrays, and even arrays of objects will be inferred as arrays of tuples, everything. It looks like this. I will not repeat this slide. I will just say everything works. Okay, and it can be used for CSV and TSV. And you can even use it for schema on demand. Imagine you don't want to specify schema for your files, and it will be detected as a string, but you can use this operator like colon. It is the same as in Postgres to specify data types on the fly in your query. And it is supported for some unusual formats like line as string. Line as a string will read every line of your file as a column with name line and type string. And I can use it to read HTML. In this example, I read the famous Hacker News website, my favorite, and I do it inside ClickHouse client because I don't want to lose my attention. I don't want to exit from ClickHouse client. And it works for some formats with separate schema like protobuf. You just provide the schema as a setting, and it will be converted to table definition. And even more, it works when you create a table. So recently, you have to always specify the structure of your table when you write create table. But now, if you create a second replica, or if you create another, if you create descriptive table, it will automatically grab the schema from shards. You don't have to repeat. And we also auto-detect format and compression when you do into out file or from in file or ClickHouse local. Okay, it was just the first feature, but my favorite. What is my second favorite feature from the last half of year. Maybe it was also pronounced. What is my second favorite feature? Why no idea? ClickHouse Keeper. You are absolutely right. So ClickHouse Keeper is a replacement of Zookeeper. When you use ClickHouse, you have to also provide something for coordination. And until recently, you had to use Zookeeper. And I don't know about you, but I don't like Zookeeper. And also, may I ask you a question? Do you enjoy managing some code written in Java? Do you like Java? Maybe anyone in this room?
It depends compared to what.
I assume that maybe you like Scala or Kotlin. By the way, Java is not a bad programming language. It's great technology, by the way, and Zookeeper is also good. It works. And this is the most important. But when you use Zookeeper, you have to configure it, and it will look like some foreign component in ClickHouse infrastructure. You have to specify JVM heap size. You have to tune garbage collector. And it will use different configuration files, and you have to use separate servers. But now we have ClickHouse Keeper. ClickHouse Keeper is complete drop-in replacement for Zookeeper. And you can use it not only with ClickHouse, you can use it with your Kafka or Hadoop or what else? Basically with everything. And maybe you will prefer some code written in C++ to some code written in Java. It depends on your experience. But with ClickHouse, it gives even more advantages. You can run ClickHouse Keeper directly inside ClickHouse server. So you don't have to use other servers. So if you have 3 replicas, just configure ClickHouse Keeper and it will be embedded into ClickHouse. No separate components anymore. Oops. We'll skip it. But who did not notice what it was? And who noticed it? Maybe you will explain me what it was.
That was memory over commit.
Yeah, it was about memory over commit, and it is one of my favorite features, but I suspect not many of you will choose this feature as very important because, again, it is not visible as some new table engine or new data type. It is just some improvement in fundamental behavior of ClickHouse. But we have a t-shirt for you. Let's look what it is. So, 1 year ago, you run some big query in ClickHouse. And it will throw exception by default after consuming just 10 gigabytes of memory. What if your server has not 10 gigabytes of memory, but 2 terabytes of memory? It will still be rigid. You have to configure it. You have to change this configuration to set it, for example, to 1 terabyte. But what if you have 100 concurrent queries? And you will have to think what this memory limitation should be. Should it be 1 terabyte or 100 gigabytes? It is not obvious. But now you don't have to configure anything. And it will work automatically. you can have one query on your server and it can consume almost all the memory, like terabytes. If you have 10 or 100 queries, they can start and try to use all available memory. Even if it is more than some soft limitation, you still can have hard limitation for your queries. But if queries are above the soft limitation and memory is not enough, we will select some queries and some of the most hungry queries will throw exception. Are you excited about this feature as much as I do?
Yeah.
Only one person. Now I will ask you another question. What is the size of memory on your production cluster? What is the amount of memory?
Per node or per
Per node.
256.
256. Yeah, quite good. Right? Maybe someone have even larger cluster. I suppose you use ClickHouse on some cheap virtual machines.
Yes.
It is also fine. ClickHouse will work even if you use it on your laptop. It will work. It will not complain about your laptop. Okay, what is the fourth? My favorite feature. I will give you a clue. This feature can optimize query performance. And this is not anything that Maxim has told. It can optimize performance from different standpoints.
Is it joins?
What about joins?
New types of join engines or
No. Joins, maybe it will be the next step. But now I would like to tell you about different optimization. It was contributed by external contributor from China. And it can magically optimize your queries. Absolutely, projections. You are the winner. We will give you another t-shirt. Projections. What it is, it allows you to have multiple physical representations of your data inside your table. So you create a table and you have to set up order by key or primary key. And you can set up only one primary key. But what if you can have another primary key and some subset of queries will benefit from it? You can create another table. You can create materialized view. But then you will have to manage this materialized view. You have to take care for the data to be consistent in different tables. But now with projections, it is much more easy. You just create projection and you can create it for different order of data, or aggregation of data, or subset of columns, or some filter of this data. And what is the difference from materialized view? First, consistency guarantee. If data is inserted into table, all projections will also reflect this data, unlike materialized views. So it is also atomically insert data into every projection. And even more importantly, this optimization works automatically. So when you do select, it will automatically choose the projection to run your query. Let's look how it works. You just create a table and you can create any number of projections. It looks like this. You take some select query with some aggregation and create a projection on top of it. You can add projections dynamically with filter table, add projection. You can remove projections. Nice. Okay. And the fifth item, what it will be. And to give you a clue, I will tell you that if you use ClickHouse, you need this feature. You need this. What it can be. And basically not only with ClickHouse, with every system, you need it. What?
Graphical user interface or
Graphical user interface, maybe you need this, but I can I can live without graphical user interface. I will just use ClickHouse client. Benchmark. Why do you need benchmark? ClickHouse, you know that ClickHouse is fast without any benchmarks. It's about performance test, but not. Performance test is that we have for maybe 5 years already. Drivers for some programming languages. Yes, you need this, but it is not new. I really want you to give me the correct answer. What it can be? More hypothesis. What do you need to make your system safe? What do you need with every system? What do you have to set up? Backups. Perfect. Now we have embedded support for backup and restore. Before this feature inside ClickHouse, you had to use some separate tool. Well, you have to write some scripts to automate backups on your own. But now, in ClickHouse, we have support for full backups, incremental backups, backups of databases or for all the cluster, or subset of tables, or subset of partitions inside tables. And it is using atomic snapshot for merge tree tables. Okay, let's look how it works. It looks very easy to use. You just write a query backup table to file. And you can use just a directory in the file system or zip archive. Or you can create incremental backup. With incremental backup, you have some previous backup, and you use this previous backup as a base for the new backup, and it will use less amount of space. And you can backup not only usual tables, you can also backup users, grants, functions, everything. If you look in more detail, it will be not so easy. It looks like this. This is the full specification of backup and restore command. Yes, you see, you can backup table, and you can rename a table when you do backup or restore. You can specify partitions. You can backup dictionaries, databases. You can exclude some tables. You can even backup temporary tables. I don't know why. I asked my colleague, why do I need to backup temporary tables? But then I start to think, maybe I will create temporary table, and after a minute I will think, oops, I want this table to be not temporary. And the solution is to backup this table and restore. And I can specify a file or virtual file system. So maybe it looks complicated, but it covers all your needs. Actually, 5 is not enough. I want to give you more features. And I want you to guess what will be another my favorite feature. And I will give you a clue. It is not about software, or at least not only about software. What it can be.
New office?
Yeah, new office is kind of nice, but yeah, maybe it is my favorite feature. But it's not the feature of ClickHouse itself, it's more about the team. Support for absolutely support for ARM, ARch64 CPUs. So it is about hardware. And by the way, the first build of ClickHouse for ARch64 was in February 2016, 6 years ago. And only now we have a statement that we have full support for ARch64 because we have tested it on let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I also count different generations. So 13 different ARM CPUs. And we have tested that ClickHouse works on every of these CPUs, even on some secret Google CPUs that are not secret anymore. There was a press release about 1 week ago about the CPUs in Google Cloud. And actually, the amount of work is quite large. So now we have automated builds, full integration with CI, continuous integration. We have packages, Docker images. We have automated performance tests, full functional tests. JIT compilation also works on ARM thanks to Maksim. Query profiling works, and some libraries have not been ported to ARM yet, like gRPC. But if you don't use gRPC, you have everything, and you can run ClickHouse in production on ARM machines. We even have tested cost performance, and it appears that you get, if you run just one query, one after another, you get about 30% better performance for the same price in AWS. And even more, if you run all the queries concurrently, and your server is constantly overloaded, you get twice more queries for the same price. So maybe you will find it useful for you. What else? It was only about production grade features, but we also have experimental features. And for experimental features, I will not ask you, I will tell for myself. Mainly 2 major features that are scheduled for the end of this year. First is support for semi-structured data, and another for transactions. And if you need these features, I'm going to ask you, do you need these features? And if you will ask, yes, I do, I will not give you a feature. Instead, we will implement these features. So, do you need these features? And why? Yeah. Okay. I will repeat just in case. So, you are you may be not using ClickHouse only because it does not support for JSON data type. But we will have this support in this year. I think in Q4, maybe in December, if so for Christmas. If we will not have it for Christmas, we will have it for New Year. If not for New Year, we will have it for Chinese New Year. But at least this year, it depending on how do you count. And about transactions. Do you need transactions in ClickHouse and why? No idea why do you need transactions. I need transactions and I will explain why. So imagine you just need to do consistent insert into many tables. You have 3 tables, you do insert into these 3 tables, and what to do if data is inserted into one of them and not inserted into another. Maybe you can work around this decision, this behavior, but don't worry. Or imagine you are doing some dashboard and you have a graph of your data. Don't worry about this laptop. And you have a graph of your data and you have a table. And you want to do 2 select queries, but from the same snapshot. And how to do this? To get 2 select queries from exactly the same data. If data is updated at the same time, the only answer is transactions, and I need transactions. So even if you don't need, my team will implement this feature. And about semi-structured data. Let's look how it works. It looks like a new data type, a data type named JSON. And you can just insert arbitrary JSONs instead into this data type. And it will be automatically analyzed for subcolumns and for data types of these subcolumns. What are you doing?
I have a seashell slide now.
Need to unplug the clicker.
And you will be able to query the nested data very naturally. Let's look. It also should work.
Yeah, sure. But laptop is almost done, so we need to turn the charger.
Okay. So let's look how it works. You can already store JSON inside ClickHouse. You just simply put this JSON into string column. And you already have multiple functions to work with JSON, like JSON extract string. And you specify some path, like I want to extract from teams field and take the first array element and extract from name field. It will work, and it takes just half a second. And half of second, it's pretty nice performance for analytical database. And maybe I will think that it is a good performance unless I will see how it works with the native JSON data type and how more convenient the query is. Just compare some obscure function and just this natural way to query nested data. And it takes only 15 milliseconds comparing to half a second. I will not tell you how many times it is faster because I am lazy, I don't want to count. You can introspect what is inside, but I don't recommend to do it. JSON can be quite dirty. It can have multiple fields. Everything will be processed automatically. So what you get? You get flexible schema, and you can even have some columns with strict data types, some columns with JSON data type, and queries will work as fast as for strict data types, even if we use JSON data type. We expect it will be production ready in Q4 this year. Actually, I would like to ask the developer of this feature, but he did not come to this meetup. He is currently working on this feature, and I don't want to interrupt him. And as a bonus for this semi-structured data types, we also have support for new column representation in memory and on disk. It is named sparse columns. Sparse and content will automatically optimize your data if you have just a few values. And most of the values are defaults or zeros, empty strings. It works maybe somewhat similar to low cardinality, but you don't have to specify it. It will work automatically if you have this setting ratio of defaults for sparse serialization. It will automatically optimize your storage, and queries will also process faster. And about transactions, we will have everything like in, real databases, like Oracle, Postgres, boring ones. And we will have the same boring stuff, like ACID with snapshot isolation. It is already available for preview. You can already experiment with non-replicated tables. And there are new statements like begin transaction, commit, rollback, and you will get atomic inserts, atomic selects for multiple selects from the same snapshot. And it will even work for update and delete. The feature is already available, and I want to encourage you to test it, especially if you will test in production. Actually, it is still experimental, so better to test on your staging environment. What else do we have? This is not about ClickHouse server, but I also find it very important and useful. It is about new documentation. And for new documentation, the most important is not a new template, not a new website, but the most important is people. Now we have people dedicated to our documentation. So it has many tutorials about integrations, how to start using ClickHouse, how to integrate ClickHouse with Airbyte or Kafka or Postgres, everything. And what about new documentation? Actually, it is good because the website is also fast. Not as fast as ClickHouse, but actually fast. And what else? It is one of my favorites, and you mentioned it about benchmark. So we have a new benchmark, and what is the most interesting is that this benchmark is not about ClickHouse. You might think that okay, you just have this benchmark to promote ClickHouse, to tell that ClickHouse is faster than everything else. But actually, I know that ClickHouse is faster. And you also know, you don't need this benchmark. But I need this benchmark because I want to compare every other database with each other. We have about 20, maybe 30 different databases, including self-hosted, including some services. And you don't have to even look at ClickHouse performance. You can select some subset of databases like show me only MySQL compatible databases, or show me only column-oriented databases. And you will compare something like Redshift with Snowflake. And it should be interesting. At least it was interesting for me when I prepared this benchmark. And we have a new website. What is good about our website? It has dark theme, it has light theme, and it is fast. And what is next? About these features. I have a huge list of some unusual, some weird features that maybe we are not going to implement. But if you will tell me now that you are interested in something from this list, we will have more motivation to implement it. So it's time to collect your votes. What do you need from this list? Maybe you need vector search. Maybe you don't even understand what vector search is, and you just need some explanation. Maybe you need to run ClickHouse on GPU. And if you need it, I will tell you to explain. Maybe you need to process text data inside ClickHouse.
Could you tell us what the batch job mode is about? Like, how it would be different from like running a normal query overnight?
How do you run normal query overnight? Do you go to bed later or wake up earlier just to run your query? Then you don't need this feature. But maybe you write a script. And when you write a script, what language do you use? Python. Maybe you will be happy to not use Python and use ClickHouse. Just create a batch job with SQL.
Yeah, maybe, but I need to do like some massaging over it to consume the results of the query.
Yeah, and maybe you have to specify dependencies. Like run these 3 queries first. When the results will be ready, run these 2 queries.
Yeah, but it's inside the Python.
Okay, so probably you are not convinced. And you don't need this feature. Please give microphone to someone else. Okay, please explain me why.
So I am looking at a company that we are really small and we struggle with backups. So we have also in United States, and I'm finishing with work at 5 on Friday, and they are working, and then I need to wake up on Monday at 7 a.m. to back up everything because we don't have this authorization, and I'm looking for a solution.
Okay, and we will implement this for you. Yeah. Okay, so if we are going to select just one item from this list, it will be batch jobs. Or maybe you need something else?
Yeah, so maybe.
Okay, just maybe some great ideas because okay, I can talk about what's batch jobs doing like in other systems.
Forget about batch jobs. It is already selected. Okay. About something else. Okay, just batch jobs. We will cross out. Thank you for listening. I did not expect that you will guess correctly even one of these items.
But nevertheless, if you have questions, please.
Thank you. And I have a question regarding pretty interesting feature backups. You mentioned that it works like incremental, and let's imagine you have some silly users of ClickHouse who time to time change data in the past. Will that incremental backup support that changes?
Yes, they will support these changes. They will just look what data parts are modified and what are not. And if you change data in the past, backups will be slightly larger.
Wonderful. If it works with sharding clusters, I guess?
Yeah, you can backup data on every cluster with just one comment.
Wonderful. And the last question, where can I find it in documentation?
Documentation is on the way.
Thank you.
When you talk about ARM, you mentioned that you tested it also on the Google Pixel. Do you have an actual use case for running ClickHouse on your phone, or did you just do it because you can?
Just because we can. No use case at all.
I like it.
Continue conversation about backups. You said it's incremental backups. And for example, I lost one of my backup during the journey, for example, the base, I know like on the next Monday, and I lost some of the files. What will be in this case?
In this case, you have to create not only incremental backups, but also some checkpoint full backups periodically.
Okay. And can I, some maybe to, so your suggestion just like to create a full backup for a new store, but can I, combine some incremental backup in one file? To save some place for my databases, for storage, so on, no?
So replace incremental backup to full backup, or just collapse, not to incremental. There is no such feature. So you are the first who is asking.
Maybe it's a good point to implement it.
Maybe.
Just thinking about it. Thank you.
Hi, thank you very much. I just was curious about this Zookeeper thing that you implemented. Could you just elaborate a bit more? Is it like only like wired protocol Zookeeper thing and the inner sites are your own? Because you're mentioning it's like supporting version 3.5 or similar, and how it's like evolving with the evolving of Zookeeper version. So, or you just, kind of treat this one and use it for your needs, and you don't need more Zookeeper features by itself.
We need some new Zookeeper features, and even more, we need some. We can implement some special extensions to this protocol that only ClickHouse can use. But ClickHouse will remain compatible with Zookeeper, so it will switch between like just Zookeeper protocol and with some extended features. But basically, it is full implementation of Zookeeper protocol and data model. But what is inside, we have different formats for snapshots and logs. And by the way, they are compressed and they take less amount of space. And ClickHouse Keeper takes less amount of memory. And it is using different protocol to communicate between different ClickHouse Keeper instances. So you cannot take Zookeeper cluster and replace one just one node to ClickHouse Keeper. It will be just pushed away. Zookeeper will not recognize the new ClickHouse Keeper.
Okay, thanks.
First of all, thanks for presentation. Fascinating. And the question related to flexible limits for RAM. Could you please explain a bit, maybe deeper, the logic is standing behind assigning limit to particular query? And for example, how is it working for volatile workload? For example, when it is aggressively growing, how you are avoiding like memory saturation, And for example, if it is decreasing, how are you avoiding that, like misusing all the capacity?
You can set up two settings for query or user. First is hard memory limits, and it will work as before. So if query try to use more than hard memory limit, it will throw exception. There is also some number that is named like memory overcommit denomination ratio. It is some score, and if there is not enough memory, actual memory usage for every query will be divided by this score. So you can have more queries with more priorities and queries with less priority. And you can also set up, for example, hard limit for user. Like all these queries for user should use not more than 50 gigabytes. And every query from this user will be calculated against this hard memory limit. And if this hard memory limit is going to be exceeded, the most hungry query will just throw exception. The most overcommitted query according to this scores.
Okay, thank you.
So about the projections that you presented. So in ClickHouse, you also have live views as an experimental feature at the moment. And it seemed to me just from your presentation about projections that the use case of live views and projections is pretty similar. So maybe you can elaborate how they different or what the different use cases are for them.
They are totally different. So projections are to store some data, pre-processed data, to optimize your queries. You can store aggregations. These aggregations will be prepared on insert. They will stay around. They will be written to this and so on. Live views are different. It is about subscription to updates for your tables. And yes, you can have aggregating live views, and yes, they will receive the updates and do final aggregation. But it is mostly about real-time updates while keeping these pre-aggregations in memory. And projections is about persistent data that is always around and always can be used.
Thank you.
So you talked about new features, and I'm just wondering, do you drop features from time to time? Sometimes it is not easy because when we want to drop some feature, there will be some developer, some engineer who will say, I need this feature, why do you want to drop it? Then, do you have any type of telemetry in ClickHouse? Let's say I install ClickHouse on my cluster and I want to report, so you know the distribution of what people are using outside of your cloud. Your question sounds even slightly offensive to me. Okay, because we have a ton of telemetry built into ClickHouse, and we have everything. You can get the metrics about all the clusters. You can get the metrics about every query, and you can get the metrics about everything. How much data was read, how much data was processed, how much data was written. You will get metrics from the operating system, from Linux, about how Linux think about ClickHouse, is it? What I meant is from third party, not third party, but let's say I install ClickHouse on my cluster. And what I meant by telemetry is that if I flip a flag in my cluster, you, the ClickHouse team, will get my telephone.
Ah,
That's
no,
what
no,
I
no.
meant.
We don't have
You
any telemetry. So ClickHouse will not ring the phone. We don't even know how many ClickHouse clusters are in the existence. Maybe 10,000, maybe 100,000. I don't know. We just care about the product. And we don't want to send you email about your ClickHouse.
All right, Alexey, thank you very much.
We have even more time for questions.
Yeah, but we got pizza that's getting cold as well. So otherwise, we could just continue the conversation while we're outside, having a bit of food, whatever the people here prefer. I see nodding, so let's do that. Then we can just continue the conversation outside with whoever you want to talk to. Feel free to reach out or walk up to one of the ClickHouse shirts people, and well, also to me who answered the question correctly. Please come to me, and I will give you one of the shirts. One of you. So let's do that. Let's walk outside, grab something to drink, eat something, and continue the conversation. But first of all, thank you very much, everyone involved here. It was awesome having all of you. Alexey?
Thank you for listening.